Folks, and welcome back to my basement. I'm here today to demonstrate how to use STATA software for the very first time. You should be following along up to this point with the prior video of how to access the University of Iowa virtual desktop if you need to do so. Otherwise, if you have access to STATA through some other means, you can start playing along with us that way. I am then picking up essentially on page 5 from the handout describing how to get to the virtual desktop. So I've gone through the steps already. Here is the set of menus, and I've opened up STATA. So let me get rid of that and show you then what this looks like. So welcome to STATA. STATA has separate windows for the output that you are requesting and the syntax files that generate them. So the first thing that we need to do is open a syntax file. So I am going to hit open as I demonstrate. And since I did this last time, it's already going to the place on OneDrive where my syntax folder is. I have a do file, as they are called. .do is the extension for STATA. That is STATA syntax. So we'll go ahead and open it. And as you can see, it has generated another new window. So I'm going to go ahead and move these so that we can see everything that's happening at the same time. I think that will make it a little bit easier to work with. Over here, this history panel, you don't need. I'm just going to get rid of it. And then I will resize this window so that it fits as well, or thereabouts. All right, so welcome to STATA. I got a chance to start using STATA when I had to learn it to teach for workshops, and I've gotten so that I like it quite a bit. It has some really nice features that make doing data analysis really easy because that is what it is designed to do. So the structure of the syntax file is what I want to walk through, sort of what things are doing and the logic of it, and then I'll show you what it looks like to actually run things and generate some output. So the first things that I have in this program, yep, I can zoom in, excellent. We'll just make this a little bit bigger so that the recording works better. There we go. The first thing that I have in my programs for any package is whatever options I need to control what the output looks like. So in this case, I have a command, so you can tell that it is a STATA command because it's in blue, set more off. What happens in your output is that it will ask you to hit a button to see more output. So it doesn't automatically just fill the page. That can get annoying, so I shut that off. And I also can control how wide the output is in case I want to copy some output and paste it someplace else. So these things are some options that you may find useful. You'll see a whole lot of green text in my examples. In STATA, the green text refers to what are known as comments. These are instructions that you can leave to yourself that the computer will not read. So there are actually 3 or 4 different ways to make comments. The one that I tend to use is 2 slashes like this. This is a single line comment. You can also just do 1 star all by itself. I tend not to use that one because then the code looks more like Sass to some people and that could get confusing. So I stick with that. You can also do what is known as a block comment for a multi-line set of instructions to yourself. So this one, for instance, demonstrates a block comment. I have a slash and a star to begin it. I have several lines of notes to myself, and then I end with a star and slash. So that creates a block of text that it is essentially going to skip over, but that would be part of your documentation. And so I have a note here about colors. Comments are green, STATA system commands are blue, 2 different shades of blue. Things that you would need to change, such as variables and file names, are going to be black. File references, so where the file actually is, are in red, and they are case and space sensitive. STATA has to be lowercase for all of its dedicated commands, and otherwise names of variables are case and space sensitive as well. In earlier versions of STATA, it required what's known as a line continuer. So if your command needs to span multiple lines because it's really long and complicated, you would need to tell STATA, hey, don't stop when you get to the end of the line, keep reading. And the way to do that is 3 slashes like that instructs STATA to keep going. So you will see me use this in my code to make sure that it is backwards compatible with older versions of STATA in which this was required. Another thing that has changed in STATA is that it used to be that you could only have 1 dataset open at a time. There is some way to do this starting in STATA 15, but all of my code works with the old version, again, for backwards compatibility. And one other piece that I'll note here, the keyboard shortcut to make things go is Control plus D in Windows, and I believe it would be Command D under the Mac. All right, so you will see these kinds of comment headers that separate sections of my code. This is just me trying to make my code easier to scroll through when I'm in a hurry, and it also sort of tells you what the steps are that are being executed afterwards. So as I made a point of in the last video, the hardest part sometimes is just telling Stata where your stuff is. So within the virtual desktop, you would want to open Windows Explorer and then find where your stuff is. So I'm going to demonstrate this here. I'm going to navigate inside the folder. So note you want to go all the way down to the level at which the files are. Copy the path, and then you can put it in like that. Ta-da! If you had wanted to use a file location that was stored on your local machine rather than something that is stored in the cloud or remote, then you would have to figure out where that is. And so I have an example down here that I'm going to uncomment for a second. So this version is what it would look like if I were navigating to the laptop C drive that I'm currently working on right here. Notably, it has this extra component to the front of it that you would need, and so that can trip up people. Now, because I'm not working with that file structure, this is an example of using a comment to shut off code. So I have essentially shut off this line, but I'm retaining the line in here for my future self to use as needed. So if you have code that you want to save for reference, but you don't want executed, you can turn it into a comment, and then it will be skipped over, but not forgotten in your file. So step one, we got to get some data in. I am going to use Excel data in this class. That way you can see it outside of these packages, and every different type of software package can read in Excel data. A convention that I follow in STATA is that because there's only one data set open at a time, you want to make sure that you're not confused as to which one is open. So I have this clear command that means if there was any data open, please get rid of it. And then there is a STATA command, import Excel, that does exactly what you think it would. So note the red text in quotes here. This is the name of the data file that is inside this folder right here. So you only need the name of the file and the extension at this point. One unique thing to Excel data is that you can have multiple sheets of data. So I have to specify which sheet name in particular that I want. And note that anything that's in this red text here is case and space sensitive. And I also have another clear command here. That means if this data was already there, what I want them to do is re-import it. So this is helpful if you screw something up in your data and you need to start over again. Then this clear allows that to happen without having to go to the trouble to formally close it. All right, so next up then, these are more sort of preliminary steps that, oh, I know what's wrong. This little return thing over here is set. I don't like that thing, so I'm gonna get rid of it. There we go. So we're going to let the text continue past. That way it's allocated how I wanted it. So again, more preliminary steps once we import the data. Let's go ahead and do that actually. So let me show you what's going to happen. We're going to run these data commands up here. You can either do Control D or you can hit the run icon. So execute selection is what it's called. We're going to do that. So then over here, it echoes back whatever you asked for. And there's nothing that's visible with these commands. They're just controlling what the output is eventually going to look like. So if I want to import data, now I'm going to highlight this chunk right here. Technically, I just need to highlight the one line. I'm going to hit Control D, and it goes over here. All right. So now, if we go over to Data Editor Browse, we should be able to see it, except it is not here. So my goodness, what went wrong is the next thing we got to figure out. Ah, I know what I did. I hadn't run it yet. Haha. No wonder the data is not there. I hadn't run that step. So this is a good unintended pedagogical demonstration. So this does not generate any output because all I've done is tell it where it's going to look for things. The import step is what actually does that. So I will highlight just this chunk and run it as well. And there we go. So now over here on this pane, we have a list of variables and the labels that came with them. So in Excel, it just says these names, and so Stata just adds those to the label column just as a default, but they're not particularly useful labels, as you can tell. We will solve that problem in just a minute. So that's our data set. If you want to look at the data, we can go up to the data option, data editor, browse, and there it is. So it is always a good idea to do this step. Just open it up and check, see if it looks the way that you think it should. You can see if the variables are what you think they should be. And note the case and spelling of these things. Most of these are going to be lowercase, but I have a convention of ID variables named this way, so I'm going to stick with it. Each of these has different properties in terms of what kind of value it is being stored as and how many, what the level of precision is as well. So we don't need to keep seeing that, but I just wanted to be able to show you how that works. So we don't really need to see this column very much either. I'm going to scoot that over. There we go. All right. Now, if you are somebody who does not like this log being cluttered up with things that you no longer need to see, under Edit, there is a clear results window, and now we can get back to the fresh version. Okay, so we've got data in. Hooray. Next up, I am defining what are known as value labels. So what this next piece of code here, starting on line 39, is doing is creating conventions. These are labeling conventions that are going to be stored in Stata's active memory, and then we can tell it to apply these labeling conventions to our variables. So I have two to demonstrate how you might do this. So fMarital right here, so label define is the command. That's dedicated Stata command. fMarital is the name that I created. F to me stands for format. Marital is the type of variable this format is intended to apply to. So what I'm saying is if you have a value of 1 in that variable, in this labeling convention, I would like it to be this. If you have a value of 2, I would like it to be this. And note that I put the numbers in front of the verbal labels so that the verbal labels stay in the same order. Otherwise, when I get my output back, Stata will sort it alphabetically, which is probably going to be confusing given that I put these variables in the order in which they were. Likewise, here's an example, by the way, of a line continuer, because this entire command needs to be read as one contiguous thing. The line continuer ensures that is the case. A second labeling convention is for a variable for happiness measured on an ordinal scale, where these are the choices. So now down here, I am going to add more informative labels to 3 variables that are going to be used in this example: marital status, happy, and income. So then label variable is the dedicated command. You list the column that you want labeled, and then in the quotes you can write whatever you want. So I think there's a ridiculous amount of characters allowed for this. You can be as descriptive as you need to be, and your future self as well as your colleagues will appreciate it if every variable is very well labeled in the data set. Then we are going to apply the value labels that we created here to their relevant columns. So label values means, hey, can you go into this column and change everything so that it looks like that? And now can you go into this column and do the same thing? So it's very handy because let's say that you had a labeling system where you wanted the zeros to mean no and the ones to be yes, and you wanted to do this for 100 variables. Well, you don't need to define 100 different labeling conventions. You just need to define one for what 0 means and what 1 means, and then apply it down here to all the variables that would be relevant for that particular labeling convention. So we're going to go ahead and do that. There we go. So now if I look back in my data set, the columns that I added labels to, those show up right here. And in my output, we will see the 1s, 2s, 3s, 4s, and 5s have more helpful labels, than what the numbers currently are. So I have a note here. Now the data set is ready to use. So what I will give you each time that I release a homework is a file that essentially does this much, right? It'll apply labels, value labels. It will help you give a template to import the data. The only things that you would need to change is where your files are and what the name of the file happens to be. So heading down here then, we're going to do some descriptive statistics like the kind that you're going to be asked to figure out for homework 1. So one thing I wanted to highlight is that STATA can be used as a calculator. The word display means print to the output. So for instance, if I run just this tiny little piece of code right here, display 4 plus 8, it does the math for me as 12. So very occasionally I will ask for calculations that are in addition, that are based on the output that you've already generated. If you need to do math on those, you can do so like this way. I will also show you a more direct way to get it to do math on saved pieces of information that were in your output. So stay tuned for that, but that is not a first-time STATA skill. All right, so let's make some output. So tabulate is one of the commands that we are going to use for homework 1. Display, again, this is essentially creating a title for what the table is going to tell me. This is completely optional, but I do it when in my teaching materials to make it very transparent as to what the output is going to be. You can do it to indicate things in useful ways beyond that. So for instance, I have students who copy the text of the homework question into here so that their output literally says like question 27 and then the answer follows. So things like that can save you a little bit of time. Tabulate means make a table of frequencies and proportions, and comma missing means include any cases with missing values. So let's make a table for marital status so we can see what the relative distribution of that looks like. This resulting histogram is something that was featured in lecture 1. So Control D, and here it is. So note that it spits the command back at you. So whatever you ran is part of your record here, and it's using the variable labels as well as the value labels. So now we can see that 337 people in our sample were married, and so on. It also tells you what percentage of the sample falls into each of these categories, and then down here it tells you the total sample size. So for instance, I believe this is the first question on homework 1 is what's the total sample size? You can run pretty much any descriptive statistic and figure that out. So there we go. Let's make a picture. So histogram in this case is what the command is, although the axis is discrete, meaning that we just want 1s, 2s, 3, 4, and 5, not anything in the middle since that can't exist. So if I run this command right here, I'm telling it to make the x-axis go from 1 to 5 and to use the value labels on this variable. So note that it generates a brand new plot in yet another window, and these apparently default to blue. The ones that I'm used to seeing default to a weird yellow color, so this is an improvement. And I have not played with this much, but this graph is editable, so you can go in and change, the names of these things, and you can customize it however you'd like. I'm sure you can do that in the syntax too, since pointing and clicking can get old real quick. So note that this plot is not going to be part of our record here. So if you want to save plots, you have to generate a separate command by which to do so. And here's an example of that. Graph export, you want to know what the file is going to be called, and it's going to be rendered as a .png file, and then replace means right over it if I already have one. So inside example 1 is the result of that plot being saved. So we have the STATA marital percentage plot, and here's the weird yellow color I was just mentioning since I did this in a slightly older version of STATA. So there it is. All right, let's get rid of the graph since we don't need that at the moment and move this out of the way. So for quantitative variables, you can use this same command of tabulate, but as noted by the comment, why tabulate may not be useful for quantitative variables. You can see that it lists every distinct value of this quantitative variable. So these are not in a recognized interval format, so they're just separate. You can't really get a sense as to how far apart these are and therefore what the distribution actually looks like. So instead, we will do a histogram and we will summarize this using other information. So this is actually, no, this is demonstrating why this doesn't look very good. We'll do that. So yeah. This is somewhat difficult. That's not going to be helpful. All right. So, but that would be how you can save it. Now, for quantitative variables like income, we're going to use summarize, and the option comma detail means give me a lot more information. So let's see what all we get out of that. This was shown in the slides as well. So we get percentiles, including the 50th percentile as the median. We get the mean, we get the standard deviation, we get the variance, skewness, and kurtosis. So we get all this stuff. If you don't want that much, you just want some basic descriptive statistics, I'll demonstrate what that would generate also in the slides. So a shorter, more compact table without the detail gives you just sort of the bare bones information. Now note that you could, down here, be typing commands and entering them. Nope, trying to copy that actually. See if it'll work. There we go. So if I type this down here, it will do the same thing. However, note that my words are now gone. So I would highly discourage you from typing things over here because then you don't have a complete record of what you've done and you don't have anything to go off of for future use. You have to recreate all the code. Whereas if I have this saved and I need to do similar analyses for another data set, I just change this a little bit and it's going to work perfectly. If I had to start over from scratch, I'd have to retype everything. So it's not efficient to work over here. Try to work over here. Let's see. So let's make a histogram for income. Another little thing. So yeah, this is now the x-axis actually understands the distances between these things, and it's essentially binned the separate values so that we can create however many groups of them that we want. So now we can see quite more readily that most of the sample makes little money and that it's positively skewed with a lot fewer people who make a lot of money. And one more example. Just summarizing an ordinal variable, since that is sometimes done, treated as numbers. So here's the distribution of the happiness variable on a scale of 1 to 5. And then here is a summary of it. On average, people are sort of happy, I guess. Not really sure what to make of that, but that's okay. Now, last but not least, it can be inconvenient to have to keep logging back into the virtual desktop to answer homework questions. So what a lot of students have chosen to do is try to save the output that they've generated and then use it later on when they're on a different computer or whatnot. So there is a way to do that without having to physically copy and paste this. It is what's known as creating a log file. So this command down here is showing how to do that, log using, and then this is a name that I gave it. So I'm not sure why it's in red since it's not in quotes. There's just no way, I don't know why it doesn't need to be in quotes. Let's put it that way. So example1 underscore stata output is something that you can create, and replace means right over it if you already have it. So the way this works is you would run this command first. And again, nothing's happening other than it's telling you that a log file is being created. And let's say that you wanted to save this result. Okay, you can do as many as you want, but let's just do one. So I'm going to copy it down here. I'm going to run that. So there it is. And then let's say that I wanted to do this one as well. Sure. Now I got these two models, and now I want to close the log. So I'm going to do that. And now what has happened is you can see it has written a file to my directory that has the output from STATA. So if I look at that, the one that I just made a second ago here, there it is. So I opened it in Notepad. You can open it in any kind of text editor. It's just straight text. So if you want to use STATA, make sure you get, all of your models run and then go back and answer the questions later using the saved output. This would be the way that I do it. So inside the homework files, there'll be commands that allow you to do this. So then what are you supposed to do when you have homework? First off here, since I'm editing this, I'm going to save it. Actually, don't want to save it. Let me get rid of what that was. Put it back to the way that it was supposed to be. There we go. All right, cool. So in homework, each time a homework is open, you would go to the homework system. I've done that once here already. So I've logged in. I'm going to get into homework 1, for instance. Now let's say that I want to use STATA to complete homework 1. I click on this starter syntax link, and here it is. So my task is now to copy this, go back over into STATA, and start a new file, and paste it. Okay? So this is my starter syntax. You'll note that I have an example of where I have an example of where the files would be, and you would need to replace this with yours. And also I have an example of how to import the Excel database, which is how your assignments will be rendered, as person 111111. So you would then change this to be your ID number. So again, change where your stuff is, change what your ID number is, and then you would just need to run all of this text. So the first assignment is a hypothetical survey of graduate students, and one of the variables is whether or not they're first gen, another is their gender identity, and then we have labels for age, undergraduate GPA, and the importance of getting a job. So I'm giving you all the information about the variables. You would just need to run it like that. So then down here, I have log using. So if you wanted to turn on the output, you could uncomment it. If you're not ready to do that, you would leave it commented. And then I have a note, your code goes here. Okay, so where does that code come from? The corresponding example. So I'm going to pull example 1 back up here. And let's say that I wanted to the question said something like, find out what the mean of age is, all right? Well, age is a quantitative variable, so my task is to look through this set of examples of how to do things and find one that matches what I need to do. I need to do an analysis of a quantitative variable, so I'm going to borrow this little piece of code right here. So I'm going to copy those two things, go back over here into my starter syntax, and paste it down here. So the things that I would need to change, if I want to do age, I would change that in the label for the output. So again, this is a title. You can put as much or as little information here as you want. I would put age here and make sure that age is in lowercase. Yes, it is. So then I would be able to run it and generate the output that I need. So at that point, I would do that. And there is a distribution of age in this data set. Age in your data set will have a different distribution as well. So really, this is the task I'm asking you to do, is to download the example file that goes with the homework, and I tell you explicitly which ones those are. Find an example of what I'm asking you to do, make a copy of it, put it over here in your file, and then change what is needed to execute it. So I would highly recommend keeping these two files separate. This is the one that goes with your assignment specifically, and the other one goes with the example data set that I used in class. So I hope this has been helpful and that you can find STATA as easy to use as I do. I am not great at STATA, but I have learned a lot over the past few years in how to do things. There's a lot more I could learn. It does a lot of things with respect to table formats and all that kind of thing. If you have questions, I'm happy to try to answer them, but also the Google would be okay for this because STATA has a lot of excellent documentation. So for instance, there's a viewer tab here, and you can put in keywords and it will come up with things. You can also type help, for instance, help summarize, and it will bring up a window that says, okay, here's the command summarize, here's the way to use the command, here are your options, here's what they mean, here's some examples, and here is the output that is automatically being generated and saved internally that you can access so that you can make it do math on it, for instance. So just having these little files here to go with the commands you're going to be using can be very helpful. So I think that's all I wanted to say about that. Thanks for listening, and I hope to see you on the other side.